Hey everybody, it's Mrs. Cassill, and I miss you so much. So I will be back Tuesday and Wednesday this week. Our kids are still not able to return to childcare, and so we are juggling who gets to come to school and be a teacher. So Tuesday and Wednesday we will have in-class content that we will go over. I'll set up Google Meets for those of you who are stuck at home like I have been all this time. um, and we will cover some new content together, as well as watch your awesome stop motion movies, which I can't wait to see. So, as far as today, which is Monday, January 24th goes, there's two things to do. So first, there's a flipping physics example problem. So we'd be making quite a bit more progress if I was there. So this is going to work like an assignment does, essentially. It'd be like me checking your notebook at the end of us doing a big in-class problem. So there's an introductory conservation of mechanical energy problem. It's a great review of how we use these very simple equations and put them together to solve a problem. So if you haven't been working on your Khan Academy, if you haven't made much progress, if you've had your life disrupted like I have, this is a really good problem to walk through. So just like if we were doing an example problem in class, take out your notebook, work along with the video, pause it so you can write down things that Mr. P says in the video, and then you should be able to check your answer at the end and see if it makes sense. If you need help or if you've got questions, please post a comment. This is an assignment, so your comment will be private just to me. So post your comment and that way I can respond to it, or we'll be able to address it when I'm back in class, right? The second thing to do today is this Energy Skatepark Lab. So this lab, the instructions here are super short because they're very thorough in your lab document. There's a link right here to your lab document, and in Canvas as well as right here, the simulation is linked. Okay, so this is a classic simulation, and the first thing I would encourage you to do is play. All right, when you load this up, it runs on a Chromebook. It runs on your phone, actually. It's HTML. It runs on any device. So you've got a bunch of different things to do. It is entirely up to you. Your instructions will tell you which part to start with. Like the basics will tell you to begin with intro, or I mean, really, you could start with any of them for the basics, but I would start with the intro one. So you have your little skater, you drop them on their track, and there they go. They are skating, right? You can absolutely attempt to destroy your skater. So if your, greatest desire is to see, can you make them fly off the end? Then yes, you can. Cheerfully, they just vanish into the distance, and you click this little green button to return them back to the world where you dropped them from. Although that creates some problems. So your instructions in here require you to activate some of the tools in the simulation, like turning on the graphs that are available, and making sure that you've got a pie chart that's representing what these energies are so that you get to see some of these things that are happening. Take screenshots. There's also some measuring tools down here. Sometimes, and isn't there a grid in this one? There is. Oh, it's over here. Grid reference point. So this is setting your zero line, which is, what do you know? Look at, this is a thing that we do when we calculate our problems, right? So I'm going to go ahead and pause my simulation. There we go. This little measuring tape. So if you wanted to measure exactly, how far something is going, you pick a place to start it, and then you move the other end of it. So like that, and it will tell you 4.4 meters. The mass is listed over here on the right side. So if you decide that you're going to have a puppy on your roller coaster track, that's right here, press the play button. Woohoo! There goes the puppy. The puppy apparently has the same mass as the person we were just using, so that's one big dog. But anyway, please play around with this, okay? I highly encourage you to do so. There's different kinds of tracks that are pre-constructed, and later there's a version of the skate park where you get to construct your own track, okay? So follow the directions in here and try these things out. It might seem pretty dull in the beginning because you're looking for obvious things. We're trying to notice things like the relationship between how much gravitational potential energy there is at the top and how much kinetic energy there is at the bottom of an incline, and to see that play back and forth. There are some critical things like the mass of the skater. We want to really explore that. There's a lot of misunderstanding about, is that relevant in calculating these energy relationships? It's in the equation. Is it important? Then there's a couple other parts down here, like it says gravity's effect on energy. The old version of the simulation had a thing where you could like instantly put your roller coaster in space. So you'd have your fluffy puppy going around your loop-de-loop, and then you could like launch them infinitely into space. It was hilarious, but it was also unrealistic. So they've removed that part of the simulation. So, but there are several other gravity settings. There's the moon, there's Jupiter, and there's a part here where I'd encourage you to play with whatever gravity setting you so choose between those extremes. And then there's some calculations at the end. It says here use 10 point. Oh, I super dislike that, you know. You can use 10 meters per second squared as your acceleration of gravity to make your calculations really easy if you want. You can use 9.8 if you would like to use your calculator. In uncertain times, I like that my calculator can still keep doing jobs for me, and I can punch in numbers and I get answers and I go, yes, I did something. So, and then there are some conclusion questions that ask you to really dig into the relationship of what's happening and really show that you understand. This is an introductory lab, all things considered. When next week, which God willing, I should be back for completely, we will get started and we will do a final lab that we would have done already by now, where you'll be digging into this physics quite deeply and for real. So this is practice with the basic concepts, and you should be able to do it quite well. One final thing with the lab, you'll notice friction is not here. When I'm here in class this week, we will talk about what happens with friction. We'll do those calculations. That's the topic we'll cover together. You're welcome to play with it today. So that is absolutely, oh, look at that. Isn't that so interesting? Potential energy is negative. And I have to think about it and go, it's because this is my zero line. And so I'm below my zero line. All right. Long speech. So that's how the lab works. That's how the simulation works. Those are the two things you need to do today. If you don't finish the lab in class, that's okay. Finish it for homework. I think I set the due date for tomorrow because we're going to move on. We won't have class time to work on it, but you know you can turn in work up until the close date, which will be the end of the semester, which is not this Friday, but next Friday. So I miss you guys so much. Thanks for working so hard while I'm gone. I can't wait to see you soon.